For number 3, you have to choose which one is correct. And I copied it right. So that would be this one right here. Okay, so for A, you have to write it as a ratio of common logarithms. So that would be log x over log 3. For B, ratio of natural logarithms, natural log of x over natural log of 3. Alright, so for number 9, common logs for part A. So you put log of 3/10 over log of A. And for natural logs, natural log of 3/10 over natural log of A. Number 12, log of x over log of 7 1/10. For B, natural log of x over natural log of 7.1. Alright, so number 15 is asking you to use a change of base theorem to evaluate. Number 15, though, is a special case that you will learn how to solve without a calculator in the next section. But for now, I set it up with changing it to base 10 log. So log of 16 divided by log of 1/2, which is 0.5. Put it in the calculator and you get the exact value of -4. And like I said, number 15 is a special case. You don't even need a calculator for this one, but we'll talk about that in the next section. Number 18, log base 4 of 0.045. This time I use natural log as my base instead of base 10. So it's natural log of 0.045 divided by natural log of 4. And when you plug that into the calculator, you get -2.237 because they're asking you to round to 3 decimal places, okay? And remember what all of this means. I keep going over this over and over again. So for number 15, that answer -4 means that 1/2 to the -4 power equals 16, and this is an exact value. Where on number 18, it's an approximate value. We're saying 4 to the -2.237, that's my exponent, my log, is approximately equal to 0.045. Okay, that's what the answers mean. We're finding the exponents. Okay. So for 21, they're asking you to rewrite this natural log in terms of natural log of 4 and natural log of 5. So I know that 20 is 4 times 5. Okay, so remember the properties of logs. The log of a product is equal to the sum of the logs of the factors. So this natural log of 4 times 5 can be rewritten as natural log of 4 plus natural log of 5. And that's all we do. For natural log of 5 halves, because they want it written only in terms of log 4, log 5, let me see if I copied it right. Yeah. So this means natural log of 5 minus natural log of 2 for now. Then we'll simplify it. Okay, so they do want only natural log of 5 and natural log of 4, and at first sight, the first step would be what I wrote right here. That makes. Oops, sorry, I'm erasing it. That makes sense. Natural log of 5. This is a true statement. The natural log of 5 halves equals natural log of 5 minus natural log of 2. But that's not following the instructions. So what we have to do is, well, I guess I can erase this. Let's start over and write it like this. Natural log of 5 divided by the square root of 4. That's still saying natural log of 5 halves. But now we are following the instructions. They just want 5s and 4s. Natural log of 5, natural log of 4. So this is natural log of 5 minus natural log of the square root of 4. But square root of 4 can be rewritten as natural log of 4 to the 1/2, right? Square root is 1/2 with rational exponents. So that 1/2, remember the properties of logs, moves down as a coefficient of that natural log. So your final answer would be natural log of 5 minus 1/2 natural log of 4. So this one was a little trickier than the other ones, but that's exactly what they want you to write. Natural log of 5 is natural log of 4. For number 27, they gave you the values of log base b of 2, log base b of 3, and log base b of 5. So we have to find a way of rewriting 16 over 5 in terms of a base 2, a base 3, a base 5, right? Rewriting them as some base to the power would give us 16. So first off, we can rewrite this as log base b of, let's see, 16, writing it with base 2 would be 2 to the 4th, and 25, writing it with base 5 would be 5 squared. Oops, let me erase that equals, that shouldn't go there. So it's kind of like this. So 2 to the 4th is 16th, 5 squared is 25. So now, using the properties of logs, the log of a quotient is the difference of the logs, right? So this is going to be log base b of 2 to the 4th minus log base b of 5 squared. And so these exponents become the coefficients of their logs, like that. And so this becomes 4, maybe do it on this side, 4 times log base b of 2 minus 2 times log base b of 5. And they gave you the values for log base b of 2 and log base b of 5. For number 27, we did not have to use log base b of 3, and that's fine. They just gave you the 3 values because for the other problems you probably needed log base b of 3. But for 27, we didn't need it. Okay, and that's fine. So log base b of 2. So 27, here I have 4, I replace the log base b of 2 with its value and log base b of 5 with its value. So it's 4 times this minus 2 times that. Put it into a calculator and this is what you get as your answer. Alright, for number 30 and 33, I know they're asking you to use a change of base theorem and a graphing calculator to graph. I'm going to graph these by using transformations, the way we've been graphing them in class. And then I'll show you in class with the graphing calculator, the process for doing that. For now, we're just going to use transformations. So here H is 1, positive 1, so that's why we're adding x plus 1 for the x coordinate. So 1 plus 1 is 2, the y does not change. 2 plus 1 is 3, the y does not change. Okay, so the graph is set up, and I drew the vertical asymptote at x equals positive 1, and now plot the points 2, 0, and 3, 1. Connect. Just missed that point by a little bit. There. Okay, so the exponent on the x, remember if we use the properties of logs, becomes the coefficient of the log. And so now I have a vertical stretch by a factor of 2. So that's why you see the 2y above the points, above the reference points. So 1, 0 stays 1, 0. And 1/4 1 becomes 1/4 2. So because of the 1/4, I skipped every other square to label the 1 and the 2, etc. So 1, 0 is here, and 1/4 2 would be about here. Okay, so it's going to go something like this. It's kind of crooked, but right there. Alright, so 36, the 3 under the x is the same as, let me just change the color, is the same as saying this. Log base 1/3, oops, 1/3 times x, right? That's the same thing. So that 1/3 inside the parentheses is a b. It's the parameter b. So remember that's a horizontal, because it's 1/3, it's actually a horizontal stretch. That's why you see the 3x above the 1, because it's a horizontal stretch by a factor of 3. So the 1 0 becomes 3 0, and the 1/3 1 becomes 1 1. Horizontal stretch by a factor of 3. So you have 3 0 and 1 1. And it goes something like this. Oops. Something like that. So there's a horizontal stretch by a factor of 3. So for 39, you have to use the properties of exponents, of logs, and simplify as much as possible. Alright, so first thing I'm going to do is, because I see this is the log of a product, I'm going to break it up into the sum of two logs. So log base 2 of 4 squared plus log base 2 of 3 to the 4th. Okay, now 4 squared, right here, I can change that 4 to base 2. So I'll do that next, and then you'll see what happens. So log base 2 of 2 squared, don't forget about that square that was there originally, plus log base 2 of 3 to the 4th. Okay, so the 2 squared square, okay, this up here, this becomes 4, right? 2 to the 4th. So I write log base 2 of 2 to the 4th of 2 to the 3 to the 4th. Okay, so now I'm going to put these 4's as coefficients of their logs. So I get 4 log base 2 of 2 plus 4 log base 2 of 3. But log base 2 of 2 is 1, right? If the base and this number are the same, then this log is equal to 1. So 4 times 1 is 1. So this becomes 4 plus 4 log base 2 of 3. And that's as simplified as we can get it. Alright, so for 42, here's another natural log of natural log of 8e cubed. It's the log of a product, so I'm going to break it up as a sum of two logs. So this becomes natural log of 8 plus natural log of 8 cubed. And this 3 right here becomes the coefficient of that natural log. So this equals natural log of 8 plus 3 natural log of e. And natural log of e here is 1, because the base is e right here, right? So this is 1. So 3 times 1 is 3. So this becomes natural log of 8 plus 3.